Hello students, in this video I will show you how to draw the scatter plot for the dataset provided, and then I will show you how to compute the correlation coefficient and explain the meaning of the correlation coefficient, and then we will give the equation of the least square regression line and interpret the slope, interpret the y-intercept, and then we will predict the distance and find the residual. So I have this question. This question is giving me the following data. The following data represents the speed, the swing speed for a golf club in miles per hour, and the corresponding distance the ball travels in yards. And we are required to find the scatter plot for this data set. To find the scatter plot, I transferred my data into an Excel sheet, and this is how you're going to create the scatter plot. So I will select my data, and then I will go to the Insert tab. From the Insert tab, I will click on this scatter plot right here, and then pick the first one. So as you can see, I created the scatter plot. I'm going to edit the title. It has taken this label. So I'm going to say this is the swing speed versus distance ball travels in yards. So that is the scatter plot. This is the first step to finding the correlation coefficient. The next step is to create or find the correlation coefficient. So what I will do, I will create a trend line and then I will compute the correlation coefficient. So I'm going to go to the plus sign and then I will go ahead and click on the trend line. Let me just move it a little bit so you can see what's going on. So again, check the trend line, and then from the trend line, I will go to the arrow next to it and I will select more options. From there, I want to find the correlation coefficient. So I'm going to display R square value on the chart. I'm going to do that one step at a time. Now this is R square, and I know that the correlation coefficient is R. And this line is positive, it's going up. That means R is going to be positive as well. And to make sure that that is the case, let me display the equation on the chart, which represents the equation of the least square regression line. So as you can see, the slope here is positive. That means R is going to be positive as well. So I'm going to go to any empty cell, and I'm going to say this is R, and R is equal to, because it's positive, I will leave it positive, SQRT. If it was negative, I would have included a negative sign in front of the square root of R squared, which is 0.9682. And the answer is this one, so R is equal to 0.98. I'm going to highlight it. Next, after we found the correlation coefficient, we want to find the equation of the least square regression line. The equation of the least square regression line is given here. So I'm going to type it down here. Y is equal to 1.4314x minus 66.086. And that is the equation of the least square regression line. Let's interpret what the correlation coefficient means. So it means that the swing speed of a golf club and the distance the ball travels are very strongly correlated. That means when the speed increases, the distance the ball travels is going to be increasing as well. In other words, there is a very strong positive correlation between the swing speed of a golf club and the distance the ball travels in yards. We created the equation of the least square regression line, and the slope is the number 1.4314, which is in front of x. That is the slope. The y-intercept is the number negative 66.086. So how do we interpret the slope? We interpret the slope as follows. Since the slope is positive, that means the distance the ball travels increases by 1.43 yards for each 1 mile per hour increase in speed, or the swinging speed of the golf club. So this is the interpretation of the slope. To interpret the y-intercept, we have to make sense of when x is equal to 0. So let's make sense of that. Does it make sense that x, which is the swing speed of the golf club, is equal to 0? Will the ball travel any distance if the golf club is still in it, not moving? No. So we cannot make sense of when x is equal to 0, which is the swing speed. And that means we cannot interpret the y-intercept. It does not make sense to interpret that. Next, we're going to predict the distance for a swing of 150 miles. What does this answer mean? When the speed is 150 miles per hour, how do we predict the distance the ball is going to travel in yards? We're going to use the model that we created, which is the equation of the least square regression line, to answer that. And we're going to say equal to 1.4314 times 150, which is x, minus 66.086. And that is how we're going to predict it. So when x is equal to 150, the distance is going to be 148.62 yards. So the ball will travel 148.62 yards when the speed of the club is 150 miles per hour. Next, we're going to compute the residual for the 120 miles per hour swing speed. So 120, when we have 120, I'm going to compute it this way. So I will copy it and it will get computed automatically. To find the residual, I know the residual is equal to the observed value minus the predicted value. This is the predicted value for 120. The observed value is the value from the chart. So the chart says when the speed is 120, the distance is 101. So I'm going to say 101 minus this number. And the answer is negative 4.68. So how do we interpret that? How do we interpret this number? We're going to say the actual value observed is 4.68 yards less than the expected value. Because it's negative, then the actual value, that means the actual value is 4.68 yards less than the predicted value. When it's positive, that means it's more than the predicted value. But when it's negative, we say it's less than the predicted value. Let's compute number 19, which is the distance, predict the distance for a swing speed of 230. I'm going to say 230 here, and I'm going to use the magic of Excel, and I'm going to copy down the formula, and as I copy down, it's going to take the bottom number. So if I click here, I know it's taking the right number. It's taking A23, which is 230. So the distance for a swing speed of 230 miles per hour is going to be 263.14 yards. And for number 20, we're going to compute the residual for 160. So I'm going to compute the predicted value for 160 first. And then I will go ahead and compute the residual. The residual is basically the actual value minus the predicted value. When the speed is 160, the actual value is 158. Minus the predicted value, which is we computed right here. So the answer is negative 4.94. That means we say the actual value observed is 4.94 yards less than the predicted value. I hope this video helped you, and I will see you in a different one.